What we've just learned, long division, always works. But we have another process called synthetic division, which only works when you're dividing by linear factors. And those will be those without exponents. Now let's take a look at how to do this process. First thing we're going to do is we're going to set up a chart. And my chart basically is going to contain only numbers. I'm going to take this x plus 1 that I'm dividing by and change the sign here so that I have a minus 1 in the bottom left corner. So there's a sign change. And then I'm going to look at the polynomial I'm dividing up, and I'm only going to write the coefficients 1, 2, 4, and -5, leaving out all the variables. Then I'm going to bring down my first term, always, 1, and begin a process of multiplication and addition. I'm going to take this minus 1 in the bottom left corner, multiply by 1 to get -1, add down to get 1. Then -1 times that 1 that just came down gives me -1, add down to get 3. Then -1 times that 3 is -3, add down to get -8. Then I go back and I write my variables back in. Notice I started with x to the third and I divided by x to the first. That will leave me with an x squared. So this 1 tells me I'm going to have 1x squared, then plus 1x plus 3, there's my descending order of my polynomial, plus my remainder of -8, which will go over x plus 1, my divisor. Now let me write out the steps that I just used for this synthetic division. Number 1 is set up your chart. Pretty basic. And I'm going to say change the sign of your divisor. Now let's look at what that was up above. I set up the initial stuff that was in blue there, the top row. I changed the plus 1 to a minus 1. Step 2, bring down the first coefficient. Now up above, what I had done is I brought down the leading 1 on that top row. So I did that there. Step number 3, that's where we began this multiply and add process. So multiply the number in the bottom left by the number you just brought down. Finally, I'd like you to write the product in the next column. After you've done that, step number 4, you will add down in the next column. You will then, step 5, repeat steps 3 and 4 until done. And finally, step 6 is to convert your answer. Now, when you do this, you will always start by decreasing the exponent by 1 from your original problem. Up above here, we began with x to the third, we divided by x, we started with x squared. So whatever this is, x to the third, would drop down by 1 to give you x to the second. You will only be dividing by x to the first power because we've said you're only dividing by linear terms. If you were dividing by x squared plus 1, synthetic division would not work. Now let's practice this synthetic division. I'm going to begin by setting up my chart. Here's my polynomial 1, 4, -2, and 8, and I'm going to change the -1 that I see here into a +1 down in the bottom left corner. I'm then going to bring down my leading coefficient and begin this multiply and add process. 1 times 1 is 1, add down 5. 1 times 5 is 5, add down 3. 1 in the bottom left corner times 3 is 3, add down 11. This problem began with x to the third, so I drop down to x squared, and it has a leading coefficient of 1, so 1x squared plus 5x plus 3 plus a remainder of 11 over the divisor x minus 1. It's that quick and easy. In this next problem, we have x to the third plus 64. We have our first little trick showing up. We have 1x cubed, no x squared, no x's, and 64. So just as with long division, where you've got missing terms in your dividend, you need to watch and insert zeros as necessary for missing terms. Our positive 4 in the divisor will change to a minus 4. We will bring down our first coefficient of 1. Negative 4 times 1 is negative 4. Adding down, we have negative 4. Negative 4 times negative 4 is 16. We add down and get 16. Negative 4 times 16 is negative 64. We add down and we get 0. So our answer here will be x to the second minus 4x plus 16 with no remainder this time. Now, synthetic division is not good just for division purposes. It can also be used to evaluate polynomials. So let's take a look at this next problem and do it in two different ways. Find the value of this f of negative 2. Well, done directly, you would say, oh, substitute the negative 2 in for each occurrence of x, and then evaluate what you have left over, which is a little bit tedious, but it's very doable. Negative 2 to the fourth is 16. We would then have minus 3 times negative 8, minus 10 plus, whoops, that should be a square, so that's going to be minus, plus 5 times 4, then plus 8x plus 17. Okay, lots of little places we can make mistakes here. This becomes 16 plus 24 plus 20. And I forgot to change that to a minus 2 up above, so this is really a 16 and a plus 17, and this all adds up to 93. Notice how, lots of places where you can make mistakes. Let's try this a different way. Let's instead use this synthetic division. Using the polynomial that we have right here, I'm going to set up a synthetic division chart. It will have on the top row 1, negative 3, 5, negative 8, and 17. And instead of changing the minus 2 to a positive 2, I'm going to keep this to a negative 2. We're doing this as an evaluation. So bring down my first coefficient 1 and start this process. Negative 2 times 1 is negative 2, add down negative 5. Negative 2 times negative 5, 10, add down 15. Negative 2 times 15, negative 30, add down negative 38. Negative 2 times negative 38 is 76, add down 93. And this number that's in this last position matches what we had done the other way, except I don't have all these substitutions to deal with. It just comes out very directly. In this final problem, use synthetic division to determine whether x plus 4 is a factor. In other words, they are asking, does f of x divide by x plus 4 evenly? In other words, is there no remainder? So what we want to do is we want to check this. Let's do this division here synthetically. We have coefficients of 1, 2, negative 5, and negative 6, and we're dividing by x plus 4, so we will change this to a minus 4 in the bottom left corner. Well, bring down the first coefficient of 1. Negative 4 times 1 is negative 4. Add down to get negative 2. Negative 4 times negative 2 is positive 8. Add down to get 3. Negative 4 times 3 is negative 12. Add down to get negative 18. Now, we look at that bottom right corner, and the answer is no. Since negative 18, the remainder, is not 0, x plus 4 is not a factor of f of x.